Now we've got this circuit simplified down, so there's no more easy simplifications. There's nothing else where it's just one in series with another, or one in parallel with another. So now what we want to do is start thinking about how we're going to simplify this overall loop, this overall circuit. And we're actually at the point already where we're going to look at the different paths electricity can take. I'm going to draw them in red, green, and yellow. So let's say the red path goes through, goes up across this this part that has no resistor in it, and then it goes back. So that's the red path. The green path goes through, it goes through this resistor of resistance R, and then it goes all the way around. And then there's the yellow path where it goes through this resistor, goes through this resistor to R, and then it goes all the way around. So let's consider these to be three different resistors in parallel with one another. I'm going to draw them in a way that should help you understand what I mean. So this is the red resistor that's going to replace the red path. This is the green resistor, it's going to replace the green path, and this is the yellow resistor. Sorry that those resistors look a little bit weird. And now we're just going to have to do some calculating. The resistance for red is just R over 2 plus 2R. So that's going to be pretty easy for us to solve. It's 5R over 2. The resistance for green is going to be the same thing, R over 2 plus 2R plus R. So that's going to be 7R over 2. And the yellow resistor is R over 2 plus 2R plus 2R. And that's going to be 9R over 2. So now we know the resistances. I'm going to erase my work and rewrite these in the corner so they're not in my way, because now we have to solve for them in parallel. And you might be wondering how you can solve for 3 in parallel. The answer is kind of annoying but pretty simple. You have to solve for 2, solve it down to 1, and then you're going to take, sorry, let me rephrase that. We're going to start with the red and the green. We're going to simplify them down to 1 equivalent resistance, and then we're going to simplify that resistance in the yellow. So you just do it 2 at a time. So let's get started with the red and the green. We have 5R over 2 and 7R over 2. Let me rewrite them. 5R over 2 and 7R over 2. Now they're in parallel, so the way we add them together is going to be a little bit more difficult than if they were in series. We're going to end up with 2 over 5R plus 2 over 7R equals 1 over R equivalent. We're going to have to multiply both sides so that they're easier to add. And we're going to end up with 14 plus 10 over 35R. So it's 24 over 35R, that's 1 over R equivalent, so R equivalent is equal to 35R over 24. Let me rewrite that all so it's a lot easier to keep track of what our values are right now. So the total resistance for this section is 35R over 24, and that means that we can simplify our circuit even further, so we only have 2 resistors to worry about. Sorry. Let's see. Okay, so we're going to do this and do this. This resistor is the one we just solved for, and this one is still the yellow one, which we haven't touched yet. That's 9R over 2. And the gray one we just found is 35R over 24. So now we simply have to solve this the same way we solved the other one. So let's start adding together 1 over R1 plus 1 over R2. We have 2 over 9R plus 24 over 35R equals 1 over R equivalent. make some room. We're going to have to multiply both sides, and it's going to be a little annoying, so I'm going to skip it. I'm going to do it, and then we'll come back. You can do this calculation on your own. It's just multiplication. So when you multiply that out, you get 70 plus 216 over 315r, and that's going to come out to 296 over 315r. And then when we flip it to get the equivalent resistance, we're going to simply get R equivalent equals 315R over 296. And therefore, we've solved the entire circuit. This is the resistance that we would have if we had simplified the entire thing down to a single resistor.